let us see Kepler's third law. This is a statement: the square of the time period of revolution of a planet around the sun in an elliptical orbit is directly proportional to the cube of its semi-major axis. Right, so here we have seen that the planets are revolving around the sun in an elliptical orbit. So when a particular planet completes one revolution, right, so the time taken by that planet to complete the one revolution is known as time period. Okay, so this time period has some dependency on the semi-major axis, and the dependency is given by Kepler's third law. So Kepler's third law says that the square of time period is directly proportional to cube of semi-major axis, right? So this k is a constant here. That means if I remove the proportionality symbol, I'll get t square equal to capital K into a cube. Okay, so this is the third law, and it gives us the relation between time period and semi-major axis. Now let us see one example. If the distance between the earth and sun were half its present value, the number of days in a year would have been. So like for now we know that the number of days in a year is 365, right? So if I'm taking T1 as 365 days, correct? So this is the time taken by the earth to complete one revolution round the sun. So in that case, if I'm taking that distance from the sun and the earth as R1, so I'm asked to calculate T2. Okay, if that distance becomes half the present value, that means R2 is equal to R1 by 2. Now it is based on the concept which we have just seen, Kepler's third law, right? So there we have seen that T is directly proportional to R cube. So according to the given data and the asked quantity, we'll just take the ratio T1 by T2 equal to R1 by R2 whole cube. Okay, here we have T square, right? So T1 by T2 whole square, right, equal to R1 by R2 whole cube. So T1 we have 365, T2 is asked, whole square equal to R1. Here we have R2 as R1 by 2 whole cube. Okay, and that will give us this R1 will get cancelled, 8, right? So here we'll get T2 square into 8 equal to 365 into 365. So that means here we'll get T2 as 365 divided by 2 root 8, right? So root 8 will be 2 root 2. Okay, and when we will calculate this, we'll get it approximately equal to 129 days, right? So that means if the distance between the sun and the earth becomes half, then that earth will complete its one revolution in 129 days instead of 365.